While people are filing in, let's go ahead and look at where we're at this week. I'll put this up on the screen. Okay, so looking at Algebra 2, I like to go up to the little grade screen up here as usual to tell where we're at, what's due. If I go down April, okay, what was due yesterday was the statistics test, part 1 and 2. So you should be done with Unit 8 and ready to start Unit 9, the trigonometry unit. So what's due this Sunday is the first 2 lessons from trigonometry. You see I've already turned mine in. I was looking at it earlier today. But you should be on Unit 9. So with that, let me give you a nice overview of what these lessons will be. So we're going to start with the unit circle. And I know you had the unit circle in geometry, and I've looked at this before, but we're going to do this again here. Let me put it up on the screen. And we're going to get into it a little different way of thinking, get into it a little deeper than perhaps you did when you looked at the unit circle in geometry class. All right, so the reminding on a circle, if we have this angle right here, right? So let me get some other colors out here so we can play with this. All right, maybe those 2 right there. So if we're looking at this angle with this red line and marking right there, right? This is an angle of our circle. We always start when we're talking about the degrees of a circle. 0 degrees is over here where it's horizontal on the right side. That's where we always start measuring a circle to figure out how many degrees it is. So this would be a 135-degree angle in our unit circle here. There's another name for this angle, and it could be going backwards. If we go this way, that's negative values. So this is a negative 225-degree angle, which is the exact same angle as 135. It's going to be right there, either way. So that's just important to note, is that it can be the same angle with 2 different names. All right, so let's look at the 45 degrees. At the 45-degree angles, 45, and then of course up and down is 90 degrees. We know that. So add another 45 onto the 90, and you'll get the 135. Add another 45 degrees, and it'll get you right here with, this is 180 degrees. All right, 180 from our 0 degrees over here. So when we're talking about this being a unit circle means that's the radius. See, this goes from 0, 0 to 1, 0. So this is a length of 1. Let me write that in a different color here. The length of 1. So all of these have the same radius. They're all 1 long. That's how long all of those are, is 1. But we have 225, and over here is 315 degrees. So just keep that in mind as we're doing all this. Now, one thing we can do with this, let me get the blue pen. If I make a line straight down from there, which means it's at a 90-degree angles, we can start to discover more about our unit circle and these points. So now what I have is a 45-degree special triangle, 45, 45, 90. That's a special triangle. And what that tells us is this side, I'm going to make it an S. It's an S, not a 5, is the same length as this side. These 2 sides are the same length in a 45-degree triangle, right? And this is going to be times the square root of 2, S square roots of 2. So this is S square root of 2, this is S, this is S. That's just from the rules of a special triangle that you learned in geometry. Well, here's the thing. We know that S times the square root of 2, S square roots of 2 is equal to 1, because we said that's a radius. It's 1. So from that, we can figure out what S equals then, right? So if we divide this by square root of 2 on both sides, S equals 1 over the square root of 2. Well, we can't leave a radical in the denominator, so you multiply it by square root of 2 over 2, square root of 2 over square root of 2. That's just multiplying by 1, right? Just square root of 2 divided by square root of 2 is 1. So S equals square root of 2 over 2, because the square root of 2 times the square root of 2 is 2. So this is what that side equals. So if that side equals that and that side equals that, let's look at this point. We can figure out exactly what this point is. Because from the x-axis, this is the line where that point goes through, and we know this is how long that side is. So this is the square root of 2 over 2. And what's the height? Same thing. It starts at 0 on the y-axis, and it goes up square root of 2 over 2. So we know what those points are. Taking that a step further, here's what we did. We said 1 equals the square root of 2 over 2. These are both s. So that tells us this point, since this is the square root of 2 over 2, and this is the square root of 2 over 2, that's what this point is right here. That point right there. Square root of 2 over 2 is the x and the y for that. So now, taking this a step further, that was the 45 degrees, right? So here we have 30, 45, and 60. 30 degrees and 60 degrees, that's the other special right triangle that you learned about in geometry. And so using the same properties, this is already filled in, we can figure out that the x coordinate, the x is the square root of 3 over 2 long, and that would be 1/2. And that would be 1 again. So when you take the same thing and make a line straight down, 90-degree angle, this becomes the square root of 3 over 2, and this is a height of 1/2. And of course, this is 1 because it's the unit circle. So from that, we can extrapolate all the points. Now, if we look at them, these 3 points, and compare them to over in this quadrant, what do we see? 1/2 square root of 3 over 2, negative 1/2 square root of 3 over 2. So 60 and 120 have the same numbers. It's just that this is negative because we're in the negative x's as we go this way, right? Everything on this side of the y-axis is going to be a negative. So all of our x coordinates, negative, negative, negative. But they're positive because this is positive y is going up from the x-axis. When we get over in the third quadrant, everything's negative, right? Because everything is this way and down. So everything is negative in the third quadrant. And we get to the fourth quadrant, we got positive x's but negative y's. So you'll just see the negative on the y value of the coordinate. So we can take this a step further, talking about trigonometry. Since we're talking about trigonometry in this, I don't know if I want to use that one. I'm gonna go back to this one. Since this is the square root of 2 over 2, and this is the square root of 2 over 2. If we talk about the sine of this angle 45 degrees, right? If you remember what sine is, SOHCAHTOA, sine is opposite over hypotenuse. What is the opposite? Well, from this angle, the opposite side's over here, square root of 2 over 2 over the hypotenuse. And the hypotenuse is 1. So this just equals the square root of 2 over 2. That's what the sine of that angle is. Coincidentally, the cosine, adjacent over hypotenuse, the adjacent side is also the square root of 2 over 2. So both also equals the cosine of 45 degrees. If we talk about the tangent of 45 degrees, that is, remember, tangent is opposite over adjacent. Square root of 2 over 2 over the square root of 2 over 2. So the tangent is just going to equal 1. So your sine is going to equal whatever your opposite side is. Your cosine is going to equal whatever your adjacent side is. And the tangent is going to be a ratio of one of those over the other one. All right. Oh, something else I want to talk about. Let's talk about going around a circle now. What is the distance around a circle? I'm going to go halfway there. Well, we know a circle is 360 degrees, right? That's how far it is around a circle. We know that, 360 degrees. But these numbers here, these distances, these coordinates, we're talking about radians. Radians. May not have used radians much before, but you have used them and didn't realize it, because when you talk about the circumference of a circle, you talk about its diameter times pi. Well, the distance around a circle in radians is 2 pi. So this orange is only halfway around the circle. This is pi. That's how long it is around the outside of the circle. From 0 to 180 degrees is pi. And if you continue around over here, you get 2 pi. 2 pi is a radians measurement. That's a number in radians. So I know when you use your calculator, sometimes the teacher will say, hey, make sure you're in degrees, not radians. Well, in this, we're wanting to be in radians. But that's what this radians is. If you didn't know what it was before, that's the other distance measured with pi. So we can convert that too. Let's look at this. Convert the following degrees to radians. 270 degrees, what is that in radians? 120 degrees, what is that in radians? Well, here's what you do to convert. You take it multiple times pi divided by 180. Right? You're taking how many degrees, dividing it by 180, and then multiplying that by pi, and that will convert it. So 270 degrees is 3 pi over 2. 3 pi over 2, which is 3 halves. That's 1.5, 1.5 pi. Right? Where's 270 degrees? 180 plus another 90 is 270. So that would be down here at the bottom. So it makes sense. It's 1.5 pi. There's a pi. There's another half a pi. So 3 halves pi would be 270 degrees. About 120 degrees. Now 120, we'll look at that. That's this line here. All right, this is 120 degrees. But what is that measurement in radians? Well, it's less than pi, right? So again, we multiply it by pi and then divide by 180. That equals 2/3 of a pi. 2/3 of a pi. So going back to our circle, that makes sense, because 120 is 60 plus another 60. 60 plus another 60 is 120. Plus another 60 would get us down to 180. So that's 2/3 of it. 2, 2, 3. 2/3 of a pi would be 120 degrees. All right, let's try a problem. A ship is traveling in a circle around the outside rim of an island. Okay, so it's going around the circle. If it's 6 miles from a lighthouse at the center of the island, 120 degrees from due north. So we're saying we're at 120 degrees. We'll say start at due north. We're saying north is over here. How far has the ship traveled? We know this is 120 degrees. And we know it's 6 miles. So we have a radius of 6. So it's traveled 120 degrees. We got to take that 120, take it times pi divided by 180 times the 6, because we have the 6 radius. So let me pull up a calculator here. Do these calculations real quick. So if we have 120 times pi, I don't know if I can put that on your screen or not. 120 times pi divided by 180, and then multiply that times 6. That gives us about 12.6 miles. Take 120, multiply it by pi, divide by 180, then multiply it by 6, and you've traveled 12.6 miles. This is, I took this straight out of the Buzz. So there's problems very similar to this, or you may have this exact problem right there in Buzz. So things to remember from this. Quadrant 1, you're going to have both positive, right? Both the x and the y is positive, and it's going to be between 0 and pi over 2 radians. Because remember, pi is all the way over here, so cut it in half right there at pi over 2. So if you have a radian measurement that's smaller than pi over 2, you know you're going to be in the first quadrant. Over here you have pi. So quadrant 2 is negative for the x coordinates, positive for the y coordinates. And it's going to be between pi over 2, which is right there, and pi. So the radians will be in between there. Your angle measured in radians is between there. Get down here, these are both negative. It's between pi and 3 pi over 2. And then over here you got positive on the x coordinate, negative on the y. And it goes between 3 pi over 2 and 2 pi, which 2 pi gets us back to where we started right there. So it's 0 degree radians. So this can be 0, it could be 2 pi, it could be 4 pi, it could be 6 pi, it could be 8 pi. Any multiples, if you just keep going around the circle in distances, it can be multiples of 2 pi to get back there. So when you're talking about sine, the sine is the opposite. Sine is the y coordinate, so it's always positive. Everything's positive, sine, cosine, and tangent in the first quadrant. If you get to the fourth quadrant, cosine's positive, but sine is not. Say cosine's positive, sine's negative. And over here, the tangent's positive, but everything else is negative in the third quadrant. So we can see that. And these are in Buzz. You can print these out for yourself if you like. Last thing I want to talk about is a reference angle. Sometimes I just want to talk about a reference angle. So if you have this angle right here and it's bigger than 90 degrees, we can see that it's bigger than 90 degrees. The reference angle would be to the closest x-axis. So it'd be 180 degrees because this is 180 minus whatever this is. And they put this little prime mark on it. See, I don't know if you can see it. Like the original angle is theta, and this is theta prime is the reference angle. So when they have that little prime after it, they're talking about the reference angle. If this is 150 degrees, then a reference angle is 30 degrees. So sometimes I'll ask you about the reference angle and how to calculate that. Let's just subtract it from 180. If it's on the other side, you do the same thing, even if it's down here. If this is the 240 degree angle all the way to here, the reference angle would be subtracting 180. It'd be a 60 degree angle because that's the closest x-axis. I'm not going to go all the way around to here as a reference angle. I'm going to go to the closest x-axis, which would be backwards in this case, but it'd be a 60 degree angle as the reference angle. So that's a summary of what we're looking at this week. Of course, the lesson goes into more detail, gives you more examples, gives you more practice with that than what I gave you, but that's a nice overview look at it. So if you have any questions, hang around, and I'll see you next time. You got testing the next 2 days, so we don't meet Wednesday. No class on Wednesday. We'll see you next week.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.